You got 3-1 to 3-3. Yes. 16. 60 of which 3-3. All right. Let's see what that one says. Okay, 3-3-60. That's probably not thick enough. I probably need to do the thick with 3 C's. Beer-Lambert law of absorption applied to Lake Erie states that the light intensity at a depth of x feet satisfies this equation. Log I over 12. Oops, sorry. Yeah, that's what it says. Negative 0.00235x. Find the intensity of the light at a depth of 30 feet. Where do you think the 30 needs to go? If I'm trying to find the intensity. Do we plug in the 30 for x or I? Which one? Correct. Intensity starts with an I, folks. I'm just trying to... Never mind. Okay, so, we were trying to be nice, but you're right. Plug in 30 for x. So, log I over 12. Somebody from my second period, I'm trying to figure that out. I sent him an email. Haven't heard back from him. Yeah, but, okay, really doesn't look like your style. Well, it does match your shoes. Okay, moving on. So once I multiply these things together, what am I going to do? All right, I'll multiply them together while you figure that out. Negative 0.00235 times 30. So that's negative 0.0705. So log I over 12. Some of you are just really not taking this all that serious, and it's going to bite tomorrow. So I would suggest not letting it. Okay, now what? If it's a single logarithm, is it a single logarithm on the left side? So what form should we change it into? The one we did a bunch the other day.
Oh, you move it around.
Right, so we would change it to its exponential form. Something to the something power equals something. All right, so what's the base?
Okay.
No, folks, I don't see a base subscript written there. When you don't... Oh, 10. Oh, good call. 10. What's the exponent? Ooh, negative 0.0705. Sorry, I ran out of room to squeeze that in the box. Equals I over 12. Okay, so I'm going to use my handy-dandy calculator. 10 to that power. 0.85-ish. So I over 12 is equal to 0.85-ish. Now what do you think we should do to find the intensity? Multiply by 12. You are so good. 10.2 is what we're talking about here. Intensity 10.2 because we multiplied both sides by 12 per your instructions. Yeah, folks, it's not that bad when you realize all you're doing is changing it to its exponential form. That's really the most complicated part of this question. So, all right, let's erase that. Next.
What's the hardest question on the test?
Depends. For some, name. They leave that blank. Okay, next question. 3, and you said 51? Okay, so we're starting off with y equals 2 log 3 minus x minus 1. And they want me to describe the transformation, right? So you're starting out with just a basic log function. Now for those, all we're going to do is put this in fireproof form. Now I see two things that don't belong on this side of the equation. What are you going to do with those two things? How do you get rid of that negative 1 over there? You add it. And how do you get rid of the 2? You divide by it. Okay, now, the tricky thing left is what's going on inside here. Now, for me, I've tried to describe this to you, but I'm going to flip this around. I'm going to make it negative x plus 3 over 1 instead of 3 minus x over 1. Fireproof form said we need something with a 1x in it, a positive 1x. So what would you multiply that by to make that go from a negative 1x to a positive 1x? What would you multiply by? Okay, that's some sheepish responses. What do we got here? What are we multiplying by to take a negative 1 to a positive 1? Negative 1, thank you. Okay, if you do it to the top, you better do it to the bottom, right? So that gives me x minus 3 over negative 1. X minus 3 over negative 1. Now it's in fireproof form. There are 1, 2, 3, 4 different things you need to describe. Can you name any of them? Vertical stretch by 2. Amen. Okay, that's right there, okay? This is kind of disguised. What's going on up on the top there? That's down 1, right? Because that's that whole negative 1 thing going on there. Down 1. All right, what's going on with the 3 over here? Right 3. Remember, these descriptions are just like this. I'm not looking for anything fancy. Just, if you say stretch by 2, you better say vertical stretch by 2. That's important that you tell me which direction you think it's happening to. Okay, last thing. That is a reflection across what? Across the y-axis. For those of you who it just doesn't click in your brain about which axis you're reflecting across. Remember, I always said pick a point, a random point in quadrant 1, call it xy, and then figure out what you're changing. In this case, we're changing the x, and then decide, is that going across the x-axis or is it going across the y-axis? Most of the time when you guys visualize it, you don't have a problem seeing that reflection. Anyway, so that had 4 things in it. And you had to do some algebra to make it happen, or to see the changes. Okay. Next. The reason we went through this part pretty quickly is because it's a lot of review. Granted, you're putting several things together, but what's 7 through 40? Through 40 on section 3. She said something in the 37 to 40 range. In there, 37 to 40 range. Those were matching graphs. Well, 38 would be nice. That would be a real nice one, right? What's going on with question 38? You should be able to describe that to me. So, I'm really kind of concerned that you know what any log graph looks like. Hopefully you all know they kind of look like this. Hey, what does a natural log graph look like? Do you know what a natural log graph looks like? What? Natural log graph? What do you think? Basically the same thing. Thank you so much. I need you to understand that just because you change that base from E to 10 or 7 or 2 or 35, I don't care. It's going to have that same basic shape. The only thing that would be really drastic, which I don't think I would do to you, is if I changed it to a fraction. Because a fraction would end up flipping the whole thing. Yeah, so I don't think I'll do that to you. Okay, but those things are going to look pretty much the same. I mean, they might be a little bit different. But by and large, oh, by the way, what coordinate do they all go through right there? 1, 0, yes. All these basic log functions do that. All right, now tell me what's going on with this thing. Left 1, okay, now. So what's the new asymptote? What's the new asymptote? Ah, yes. X equals -1. And what's the coordinate it's going to go through? Very similar to this one over here, except it got moved 1 to the left. Oh, 0, 0. Can you tell me things like domain? What's the domain of that? -1 to infinity. Should that be a bracket on -1? Thank you. Can't touch the asymptote. Nope. MC Hammer. It's all over that one. If you know what a basic logarithm graph looks like, then you can start applying the transformations and think, oh, we're moving this left. Oh, we're moving it right. Oh, we're reflecting it across the x-axis. Now, if you don't know what the original log function looks like, yeah, you're in trouble. That's why understanding the basic shape of the graph is important. Knowing where its vertical asymptote is. Oh, x equals 0. If you don't know where the original one is, how do you know where it's going to be if I move the whole thing left 1? Okay. Now, I see in the 37 to 40 range, they're getting some ugliness going on there, where they're reflecting and they're shifting. I mean, I don't think I'm going to get too complicated in how I ask you to graph them, but, you should be able to look at 39 and go, oh, it moved right 3. And the multiplier was on the y side, so that means it's reflecting across the x-axis. So if you can think about reflecting this log function across the x-axis and then moving the whole thing over right 3, you could pick out the shape on that one as letter A. That kind of thing. But that's, you're just using, I'm not going to get too fancy on those. Next. I mean, we spent a lot of time in 3.3. That's fine, but if that's what we really need to focus our attention on. What else? I really would encourage you to look at the questions that second period asked, because that might be useful to you. Yes? 6 on what question? What section? 3. Okay, 3.3, number 6. Log base 6 of 1 over... That's a good question. Good choice. And what have I told you to do to every single one of these things? When it says evaluate, what are you supposed to do first? What? Set it equal to what? Yeah, remember I told you to set it equal to x? So that you could do what? Ah, excellent decision. Okay, what's the base? 6, right there. Yep. What's the exponent? Ah, yes, yes. Over here is the exponent. And that leaves one thing left. The 1 over the 5th root of 36. Now, somehow, the left side and the right side have a common base. Something we can tie together here. What do you think it's... do you think it's 6, or do you think that you're going to have to use something smaller than 6? It's 6. You can't really make anything smaller than 6. I mean, 6, I can't rewrite 6 to the power of 2 or something. So, yeah, that's it. So, we're going to have to start thinking about how to rewrite this as a power of 6. I mean, several of you would probably get the 5th root of 6 squared, but then what would you do after that? What? Okay, all right. So you're saying I'd have to change to a fractional exponent? Okay, so that would be 6 to the what? 2/5. You are correct. And that's a good idea. I like that, by the way. Okay, one more thing left to do. Make it negative. So we have 6 to the x equals 6 to the negative 2/5. If only we knew what x was. Negative 2/5. Thank you very much. Make sure you have your homework done. Make sure you have your 1 page of notes that you won't use on this test, but might use if you retake this test. Because that helps you study, plus you get a grade for it anyway. Some of you go above and beyond and do an excellent job on that notes page, and it pays off on the test a lot because it forces you to study. Okay, next. What? Oh, yeah, I can. Yeah, I love being able to get rid of it and bring it back if I need to. Got another one? Three, 2, radioactive decay. Like number 33? All right. So 3-2, number, oh, that's a bad looking 2, sorry. It's horrible. 33. All right, so the half-life of a certain radioactive substance is 14 days. There are 6.6 grams initially. Okay, do we know any piece of this equation? We know the initial value, 6.6. We know the half-life period is 14 days. If only we knew what the growth factor was. Do we know what the growth factor is for a half-life question? 0.5, nicely done. Yes. Express the amount, okay, we did that. We wrote our equation. When will there be less than 1 gram remaining? When will there be less than 1 gram remaining? Okay, we haven't gotten to the part of the chapter where we do the heavy-duty lifting with logarithms. Even though you did that back in Algebra 2, we haven't gotten to that part of the chapter. So what are my expectations? What are you going to be doing? Yeah, graphing. We'll call this Y1. What are we going to call the other side? Y2. Right, and you're going to go, let's see here. You're probably going to be looking at quadrant 1. you know, and you'll get some kind of, you know, you get something that'll be doing like this, right? How do I know it's going down like that? Yeah, because it's exponential decay. It should be going down, right? And then they're going to come through with like y equals. So we start. What number is this, by the way? Where that orange mark is? That's 6.6. Yes. So you know one's way down there. Oh, one's somewhere down in here, and it's going to cross, and that's what you want to find. Is there a calculator function that we can use to help us do that? What did you say? That's right, calculate intersect. Right? So the calc intersect feature is what you're going to be using to find the answer to your question at this point. Later on down the road when we do that question, we'll be dealing with logs. But you can graph it for now. Got another question? Yes.
Okay, just one of them from 3.1 from 15 to 24.
All right, 3.1, 15 to 24. Let's look over there. 15 to 24. All right. How about 21? So the original function, y equals e to the x. And then the new function, y equals e to the negative 2x. Okay? Can you do something to the exponent to get it into fireproof form? So right now we have negative 2x over 1, and we want to get it to be a positive 1x. What do you think we should be multiplying this by to change it from a negative 2x to a positive 1x? Negative 1/2. If we do it to the top, we better do it to the bottom. So this is the same thing as e to the x over negative 1/2. There are two things you need to describe to me. Obviously, both are happening on the horizontal side, not on the vertical side. Got any of them? Horizontal shrink. By 1/2. Okay, next. And we need a reflection. Oh yeah, we got a reflection right there. Reflection across y-axis. Some colors look so much better on my screen versus that screen. It's harder to see. It shows up a lot better on here. What about lavender? Okay. This one better be good. Yeah, that's a good one. Can you visualize? What's the original graph look like? Y equals e to the x. What's it look like? You should all know what this looks like. You should be able to draw it just quickly. If you don't know how to draw that quickly, we've got problems. What does y equals e to the x look like? It's obviously an exponential function, so your choices are growth or decay. Huh? Growth, you are correct. How do you know it's growth? Because e is larger than 1. Right? Remember, it's that whole larger than 1, smaller than 1 argument, whether it's growth or decay. So we're dealing with growth. Now, if you shrink it horizontally, all you're going to be doing is, bringing values in closer to the x-axis. It's not like a major life transformation thing. It's kind of shrinking things up horizontally. It's that reflection across the y-axis that's doing something major. What's that doing? Say it louder. I heard you say it. It makes it exponential decay. So that's the same conclusion or thought my second period class asked me. So are you telling me if there's a negative in the exponent, it changes it from growth to decay? Well, guess what? Here's another way to look at it. E to the negative second to the x. Now, what does that negative 2, or how could I rewrite the e to the negative second with a positive exponent? Wouldn't that be 1 over e squared? That's going back to your Algebra 2 days, right? That negative exponent causes the base to flip. Now, do you know anything about 1 over e squared? Do you know whether it's bigger than 1 or smaller than 1? Has to be smaller than 1. So that gives you even more confirmation in your mind that you're talking about exponential decay. Let's see if there's any other good ones in there. 19. 19 looks good. Still on that 3-1. 19. So we're starting with y equals 0.5 to the x. Is that growth or decay? That's decay. And then we do some changes to it. Now, if you move things around, fireproof form type stuff, what are you going to be doing? Subtracting 4, excellent choice. Divide by 3. So hopefully you saw these two things and say, hey, those things are affecting the y, not the x. Is there really anything going on up here to change the x? No. There's no changes on the x. We're not going left, right. We're not horizontally stretching or shrinking. There's no reflections across the y-axis. What are the only things that you see here? We should see up 4, and then what else? Okay, so here's how you lose credit. You describe to me how I'm going to lose credit. Stretch by 3. Okay, you never described to me whether it was vertical or horizontal. That's a good way to lose some credit. Okay, you do need to, even if you just put vert, period. V, period, I could even deal with that. But just saying stretch by 3, no. Anyway, so it's just kind of putting stuff in fireproof form and thinking, what does this do? What does this do? Next. Keep asking questions. You guys know where all your regressions are on the calculator, don't you? Where do you find all the regressions? Where do you find all the regressions on your calculator? Same place. Stat Calc, right? Okay. So they're all on Stat Calc if you need them. Yes. 23 on 3-1. Okay. 23, 3-1. Trying to get a little ugly here. Yeah, we could deal with it. Two e to the 3 minus 3x. Okay, I probably wouldn't throw something at you quite like this, but what do you notice about this thing right here? Does it belong there? No, it belongs on the other side. Okay, so you should at least be able to handle that part. Now, what are we going to do with this thing? All right, so first I'm going to rewrite it a different way, negative 3x plus 3. And as I have continued to do over and over and over again, I'm asking you the same question. What are you going to multiply this by so that you end up with positive 1x? What do you multiply negative 3 by to make it turn into a positive 1? Negative 1/3, right? Okay, but if you do it to the top, you must also do it to the bottom. So we have x minus 1 over negative 1/3. Okay, all I'm doing is, distributing a negative 1/3. So the fireproof form, x minus 1 over negative 1/3. Okay. Looks like I've got 1, 2, 3, 4 things to describe. Say vertical stretch what? By 2? Okay, good. Right 1? Good. Horizontal shrink by what? 1/3. Okay, good. And then? The reflection across what? Y-axis. Thank you. Yes, I know we're pushing your algebra skills a lot. It's not going to get any easier on we're just going to continue to. You need to be able to know what things you're allowed to do and you're not allowed to do. What else? Give me one more for the road. Three, 2, 7 through 18. Okay. Okay, question 10. This is 3-2, question 10. We have an initial value. That's IV. That's not, the drug stuff. But initial value of 5. It is decreasing, okay, not deceased, but decreasing at a rate of 0.59%. That's 0.59%. Can you write an equation for me? Got anything for me there? 5 goes in there. Yep. Okay, now this is where I'm worried. What does every percentage start out with? 100%. And we either go up or down from there. We are going down 0.59%. What percentage is that? 0.59. Isn't that 99.41? So how do you change 99? Whoa. 0.4. Oh, come on. 0.41% into its growth factor. Did the bell ring? I'm lost. Just sorry. I feel like people are leaving already. 0.9941. Does that help? See, I'm worried people are going to put 0.59 or 0.0059. I'm like, what? What am I doing? First, I'm going to come to school. And I'm going to answer a lot of questions. And I'm going to watch you guys take tests.